So part of my life I spent as a system integrator, as a business analyst, as a cloud software developer working across a number of different clouds. And more recently, the flavor of the day is AI, and we have a lot of new applications that are coming onto the market. So today I thought I would share with you a little bit of the experiences of building integrations to different systems and how proxies have actually been a significant help in solving some of the technical challenges that are associated with that. And a lot of this comes from an immense amount of pain, probably more pain than I would ever want to experience over the last 8 years in trying to get data out of systems and into systems in an easy way. Probably the starting point for this was realizing that there are thousands of different SaaS platforms on the market today, and every single one of the developers of those platforms have built their system to solve a specific problem for a customer, but they've done it in their own way. And part of the challenge of building a product is giving people the ability to those user experiences, but also allowing third-party applications to be able to integrate with your system, or yourself having to build custom integrations to them. And so when you buy a HR platform, you're thinking, hey, does this integrate with my Xero account so that I don't have to have all these manual processes in my business in order to get data from A to B? And in fact, in many cases, the answer is no. And so we tend to have to lean on businesses and system integrators to figure out how to connect system to system. And honestly, it's a bit of chaos out there. There's all sorts of different APIs. Some work, some don't. Some are well documented, some are poorly documented on the back of an envelope. And you come to realize that having built an integration from A to B, you think you know what you're doing, and then you go and do another one and you realize you don't know what you're doing. You've got to start all over again. And part of the problem, and probably the most consistent problem we have, is that each of these different systems, they authenticate differently. So we have basic authentication, which for those who don't know, that's a username and a password turned into a string and attached to a header on your request. That's pretty easy. An API key is probably the most common authentication method we might see today because it's actually quite easy for developers to use. We have token-based authentication, so bearer tokens that carry information about the requester, so we know and we can verify that the identity of the person or the system that's actually requesting that data. And then we have our beloved OAuth2. And for those who don't know what OAuth2 is, they call it the OAuth2 dance for a reason, because you are dancing backwards and forwards, exchanging tokens. Those tokens expire. You need to go and refresh the token. You get a token to refresh a token, and you have a really great time all the way up until someone says, hey, we need to handle an authorization code flow, which means the user has to log on. So now we've got to figure out how to get the user to log on inside our app to another third-party application. And developers just say, yay, let's deal with that, when we could be out there building features on our product and not trying to figure out how to authenticate with everything differently. And so even though we have these standards, what we also find out is that people don't follow the standards. And people add extra stuff in there, like, your header has to have this tenant ID in the header, otherwise you do not pass go. And so all of that complexity leads actually to business risk, and for a number of different ways. So we have, and in terms of how we authorize too, something I need to cover on is all these platforms authorize differently. And so for those who don't know, so authentication is just confirming that you're allowed into the system. Authorization says you're allowed to do the thing that you're trying to do. Now, the problem for us as developers is that those systems that we're trying to talk to, they all have different types of authorization, all different types of authentication, but we have no control over them. And so if their security sucks, our security sucks. Right. And so this is where proxies come into play, and I'll get into the details in that in a minute. But one of the problems with that for business is that it leads to business risk, because the number of integrations that are happening out in the world today is only growing, especially now that AI is on the scene, and AI now needs to talk to different systems. And so we have the proliferation of MCP servers out there, and it's the wild, wild west. And you don't know what they're doing with that data, but you're trying to do the best you can. And the problem for you also comes about when they change. So we move from an organization that's using an API key to a OAuth2 based authentication. And you've built all your integrations around this. So now you have to go and rebuild your integrations for a new type of authentication. And the business risk that occurs isn't just because we have this, this constantly moving, shifting definition of what secure actually looks like. It's also because as engineers, we find workarounds. And so, I won't ask you to put your hand up, but you can kind of mentally put your hand up if you like. Who's ever shared an API key with someone else, right? It happens. And who's ever, found out that, someone has left the business. Did you change the API key when they left the business? Yeah, you don't have to own up to it, but we know that it happens. And for me, the problem was when I was building integrations, I'm dealing with payroll data and an API key that a customer gives me to their system. And that key has access to 50 different customers of theirs. How do I give that key to my developers? How do I share that access in a way that actually would be secure for that customer? Yeah, we can put it in a secrets manager, but anyone who has access to it now has access to call those APIs, make use of that, and get the payroll data for 50 companies. Oh, by the way, we were building an integration for one of those 50 companies. So the business risk is significant around this. And when we look at OAuth2 as an example of a platform where, in many cases, that security has been put in place to hopefully create a more secure environment for the customer. The reality is people take those tokens, they put them in code somewhere, and then we have problems like keys being released to anyone who knows how to do a prompt injection into an AI today, because AI has been trained on what's in GitHub, right? So we need a better way to deal with this problem. And so enter the world of proxies. And essentially a proxy is, you can think of it as a computer or a service that sits in between you and that target system that you're trying to call. And that's it. That's very basic. And you wonder, well, what could I do with that? Well, the great thing is we can inspect every request that's going to go to that target system, and we can implement our own security measures instead. And so why might we want to use them? Well, first of all, it allows us to decouple our service from that target system. And that leads to separations of concerns around security. Importantly, it also adds a layer in which we can implement observability. So we can see how those API calls are actually being made. Whereas if you have a third-party platform and you have your developers hitting that platform, everyone's experiencing it now. You might be working in a team that's actually building an AI solution. You've got an OpenAI or a Claude or a Gemini credential that everyone on the team is sharing, and you ran out of tokens, and everyone's wondering, why do we run out of tokens? Who's been hitting the API? We don't know, because there's 50 different deployments out there in the wild who are all using this. We can insert that observability and see exactly what's happening. We can introduce security, and we can also monitor the performance, because in a lot of cases, what happens when you're building an integration is the system that you're talking to might go down temporarily, permanently, who knows? And guess who the customer comes back and complains to first? Guess who your product manager comes and taps on the shoulder? They're not going to a third party, they're going to you. And now you're going to go down a console log deep dive for 3 days to try and figure out where the hell this went wrong. 500,000 transactions that happened today, which one didn't make it? I've been there too for a finance company. And the problem there was 300,000 statements didn't make it to the end user. But they were in the midst of millions of other statements that did. So which ones didn't? Which ones did? Oh, wow, that took about 17 days to figure out and fix. And the customer and all their customers were not happy. So as I said, business risk, right? And for large teams, we know authentication. Different platforms authenticate differently. There's lots of different security standards that you need to keep on top of. And our integrations and observability are core challenges for bigger teams. Not the least of which is everyone's using all of those same credentials. We need a better way to share that. And so if we think about proxies again, coming back to that, and we have a target system, what a proxy would allow us to do is actually give different access to different people. So Sally might be able to make certain requests to that target system. Maybe Sally can do everything. Get, post, put, delete, whatever you want into the database. She's system admin, everything's fine. But Mike and Jane, they're not allowed. They're your junior devs, and you want to let them get some data out. You don't trust them that much yet, and you want to, or it's your AI, and you don't want to give your AI model access to this API at that level. You can implement some security protocols inside that proxy. But in the development cycle, we can also use proxies in a way that actually speeds up development. And so if you think about, the product manager hasn't yet defined exactly what this thing needs to do, but I'm meant to start coding and building my solution. Well, we can mock up an API and have that deployed through our proxy. Start building against that mock API. Let the team go and build out. And the moment where we now have infrastructure stood up in development environment, features there available to hit, just reroute that traffic over through the development, reroute it to sandbox, reroute it to production. And in integration land, this becomes really useful because sometimes the systems you're talking to don't have a sandbox. So they're sending you data through a webhook, and you're getting data coming through every single day. How do you build, and there's only a single webhook. Well, in this case, you can have that system sending data through to your proxy, reroute it to exactly where you want it to go once you've completed development and your testing and your production account. Another thing is, well, wouldn't it be nice if I just let my devs access every third-party platform using a single authentication method? Wouldn't it be great if I could take that 0 or 2 and just turn it into an API key and let my proxy handle all of the credential and tokens and all the refresh and all of that? That's what we can do with proxies too. In fact, any authentication method. And we can get more fine-grained than that. We can say, Sally and Mike and Jane, they all have different levels of access for that platform. And again, we don't control that platform, but we control access to that platform. We can put some rules and policies in place and roll those out. And then when that developer, when Mike leaves the business, we can just turn off everything that Mike had access to. And we don't impact Sally, and we don't impact Jane, right? And some observability benefits then become really clear, because now that we are in the middle, we don't have to log the body of all these requests. And in fact, I'd suggest you don't, because that's not exactly the purpose of what you're trying to do here. But we can certainly start to collect some telemetry information. We know how long it took to get a response from that system. We know when that system was down. We know how often it's down. And we can then see, get health metrics on how our integration to that system is actually working. And likewise, if you have inbound traffic to your platform and you want to, if we reverse back up a few on the slides and say you've got a client who, you've picked a particular authentication approach, and they said, well, we can't handle that because we're a legacy system and all we can handle is this. Then through a proxy, we can actually implement the authentication that they need, right? And so if we're building one from scratch, what would we be concerned about? Well, we would want to be able to support data sovereignty, because data needs to be able to flow through geographic regions. This is the great thing about the cloud today, is we can deploy our infrastructure anywhere we want. We want to have better scalability than the platforms we're talking to. That can be a challenge. We want high availability, because the one thing you don't want to do is introduce a bottleneck into an integration flow. You need to have low latency, and you want to have observability, and you certainly most definitely want to start with security as the main priority for when you're designing something like this. So encryption is critical, particularly given the fact that you're storing credentials in your platform. And you need to be able to adapt to different models as they arise. So to give you a little example of what this looks like in a Google Cloud architecture, we look at, and this is across all of the clouds, but Google as an example, because we're here today at GDG, has infrastructure that really helps us in this space. So you can think of it as a user hitting our API gateway. We want to be able to authenticate differently depending on who the user is, depending on what load they'd like to, or what resources they'd like to get. So we need a custom authorizer. We can store our credentials in a credential store. That can be relational or a non-relational database. But before they get there, we want to encrypt them. Because as much as we trust Google with the data, if at any point in time someone can get access to that data set, we don't want anyone to be able to see it. So we might have key management in place in order to be able to manage the encryption keys that we use to encrypt data that we're storing in our credential store. And then our proxy handler can handle those third-party API requests on our behalf using credentials that we store for those third parties. And it's a really interesting thing when we think about, integrating with third-party APIs, is that in most cases, a serverless application is all you need. And it has exactly what you need in terms of scalability, because every single request, your API gateway times out after a period of time. So you don't need to have a long-running process. And so serverless actually is a really good design pattern for building a proxy. But also it scales without having to build out auto-scaling groups and things like that too. So there's less for you to manage, right? And so with this kind of architecture, we can take that and we can think back to the kind of design concerns that we had around sovereignty and scalability. And so scalability, tick, high availability, tick, low latency. Well, depends on where we deploy it and depends on how we provision it. Is it going serverless? I'm sure people will say, hey, what about cold starts? What happens? What does that do to your latency? Very real question. So we're probably not looking at like real-time traffic, but certainly what we are looking at is the ability to deploy something anywhere in the world using our infrastructure on the cloud. And so one of the challenges then would be, okay, we want to build a proxy and we want that proxy to be located in multiple regions so that we can have it running as close as we can to the service that's actually operating or using it. And that's how we'll get our latency down, right? And so there's a lot of different ways that we can do this today, and GitHub is one of those platforms that we use internally in RequestRocket. But others, might be using Circle CI or other CI/CD pipelines. One of the things I like about the GitHub deployment approach is that we can set up workflows that automatically deploy that. So as we start building out our proxy, when we're merging into our main branch, we're able to then automatically deploy those changes into accounts, right? And when we started our journey building our proxy, building our platform, one of the concerns we had was, well, we don't want to have a big DevOps team that's actually doing manual deployments into all of these different regions. How could we automatically scale out and deploy to every region? And so what we found, this lovely little secret hiding inside GitHub Actions in terms of a deployment strategy, which is this matrix deploy. And what that lets us do is set up multiple deployments all happening at once across every single region the moment we hit a particular branch, right? So I'd encourage you to have a look at that, because if you're looking at, well, how do I create scalable infrastructure and how do I then scalably deploy that infrastructure? This is a particular strategy that we use that allows us, and this is demonstrated on the screen there, but allows us to deploy to currently around 36 regions across the globe all at once. Now, I said you could build all of this, and the reason I know that is because we have. And so today what I'd like to do is give you guys a bit of a demonstration of the RequestRocket platform, how it works. But one of the core challenges that we were trying to solve when we started this journey was just simplifying how we develop things by taking that product that we were developing for another customer and allowing it to talk to any one of any other system on the planet using whatever authentication they want. And so RequestRocket is a hyperscalable, cloud-native, high availability authentication proxy that translates any authentication into any other authentication that you might like. And in inserting it into a API request, that layers in all of that observability and additional layers of security in terms of what people can access and how they access it. And it turns out that this kind of service allows us to, with faster and development flows, will create faster development flows, because rather than having to roll your own authentication every single time you want to talk to a different system, we just use RequestRocket now to handle that. We pick one authentication we want for our application, for our integration we're building. We set up a series of proxies in the platform. They're available on demand, and then we can use we can talk to any manner of system that we like. Obviously, we have to navigate, however shitty their APIs might be, or however great they might be, and all of the documentation and all of the logic. But it takes away that additional effort, having to build custom handlers for every single type of authentication, for having to deal with OAuth2 and that pop up, and having to deal with that, for different platforms as they come about. So we get better observability and security. And one thing that we have done is deployed our platform across 6 continents. So that allows that low latency everywhere, wherever we need the data to flow. But more importantly, from a security standpoint, lets us ensure that not only the data, but the credentials and everything about that proxy and its operation is operating in a particular region. Because for customers who have that sensitivity to where their data is, that's really number one. I mentioned encryption, and encryption is incredibly important. So we use military-grade encryption for how we store all of our credentials going on our platform. So to demo time. Now, forgive me, because I hope this works when I get out of here. Okay, so RequestRocket is a Brisbane-based company, and we were founded about 2 years ago. We have a number of developers who are actually in our platform, currently using it in early access. We went out to early access about 6 months ago, but this is just a demonstration of what's in production at the moment. So I have already set up a proxy, but I'm going to walk through the process of setting one up. You can see that this proxy is configured to run in the Australian region. We're able to create our target credentials. And in my case, I've just gone along to a lovely little website called Free APIs and found the Dogs API. And the Dogs API, fortunately for us, requires no authentication whatsoever, but RequestRocket requires that you choose an authentication approach for a target, no matter what it is. And so in our case, we've created what I might do is actually just clear out this guy. Or actually, what I might not do is that I might create a new one. So we can create a credential for our target. In this case, we're going to just call it dogs, if I can spell, dogs, none. Just so I remember that there's no authentication on it. We can choose a bunch of different authentication approaches. Even if it was, say, OAuth2, for instance, we can go through that whole OAuth2 flow here, capture the credential. No one ever sees it, gets stored in the system, and away it goes. For us today, we're going to pick none and save that. Any credential that goes into the platform never comes out. So there's no one on your team that can ever access it again. That's kind of annoying sometimes, but given the convenience of how easy it is to create a credential, that's just something that we went with. So we've got this new target credential. We'll create a target. I'm just going to borrow this URL here again because I'm just stealing it, but just to show you how easy it is, we can call this the dogs target. Now, these things are treated separately because later on you'll see that I can swap these out at any given moment with something else. And so at the moment, when we create this proxy using this target, it's going to hit that URL for us. It's going to use that authentication that I just set up for us. But if I wanted to swap that to something else, so suddenly tomorrow, the dogs API needs an API key. We don't need to go and set up a whole new proxy. we just go and change the credential. Job done, right? So we've created our target, and we can set up a extremely secure password, or let's call it our key, super secure key, and we can just give it our super secure API key, which is going to be dogs. You're welcome to hit this later if you like. Don't hit it too hard because I don't own the dogs API and they might get a bit upset. But we've created all of the 3 ingredients that we need in order to configure a proxy now. And we go, and I think I need to remember that. We can create a proxy, and we'll call this our new dogs proxy. Now you notice as I went through that I was able to choose a region for each of those things. And so if I had chosen that key to be in a different one of these regions, then it wouldn't be available for me to set up a proxy in Australia. So if I'd chosen the US, that key can only be used in the US, and that target and that credential can only be used in the US because the data physically is stored in the US. And so for us, though, we've set everything up in Australia. Let's pick a credential. I'll pick my super secure key, and I'll pick our, I think it was dogs target, and dogs none. There's a few different options here. I'll go through those in a minute. Love live demos because they always work. And I'm just going to copy this URL it's created. I can even give it a custom path or suffix that we want to identify this, just especially for me. The only condition there is that has to be globally unique across all tenancies and all clients. We can do that. So we can give it an alias. Also, we could, if we wanted to, just come back in here right now and change that to a different credential. And we went from one credential to another. And so it's very easy for us to maintain that same base URL, that same thing that we're hitting, and then swap to a different type of authentication, swap to a different target routing, or swap to even just a new credential that we want to set up for someone else, right? Now, all of those updates propagate to wherever they need to be in real time. So as soon as that credential is set up and saved in here, the very next request that hits our platform needs to authenticate that way. So that makes rotating your keys nice and easy. I'll just leave that open for a minute. We can go over to my favorite little tool, which is this one here. Don't know if that comes up well on the screen. I might need to make it a little bit bigger. And give it that URL. Does anyone remember what my password was? It was dogs. And we can send our request. Right. So now we have dogs. We have all the breeds of dogs that API offers coming through our proxy, authenticating using, in their case, no authentication at all, but using whatever authentication the dogs API required. But we're using an API key. Now, I've decided that the user of this is no longer allowed to use this proxy. I don't want to, sorry, 1 second. This one. Okay, and we can go back over here and we can hit that using our authentication, and you're not allowed to hit it anymore. So we can turn them on and off on demand. We can do a bit more than that now. We actually come back in and turn it back on. We might want to add some rules. So we have a default rule set which says that everyone hitting this proxy can access whatever they want. So the default is allow, but we can create a deny rule in here that says, well, you're not allowed to hit the breeds endpoint at all. And so, or maybe we just deny all get requests to this proxy. Okay, I can go back over to where I was before and make that request. And we can see now that it's a different message, right? It's now matching a deny rule, and that's why you're not allowed to access it. And we add headers and other information in there that gives you information about why you've been denied and the like. Importantly, what I also get as we go through is information about every request that has just been made to the platform. And so we can see the different requests that were made. We can see the status of the proxy. So in this case, we can see that the second and third request I made were denied by our API, not by the target API. And in terms of the response from the target, there's no response. So it's basically a 407. You need to authenticate with your proxy first before you can make that request. But in terms of that first request, you can see that not only did the proxy successfully do what it needed to do, but the endpoint did what it needed to do as well. And we can force a scenario where it does the opposite of that and say, for instance, we'll just remove that rule that we had and allow that request to go through. Let's make that request just to see if it works. All right, so we're allowed to do that again. But this endpoint, from what I understand, would not let us post any data. So let's try and do it. Send some data. Hello. Okay, 404 not found. That can't be good, could it? And we can see now that the proxy has actually successfully processed the request because we got a 200 from the proxy endpoint. And we can see also that the target was the one that returned that 404, and it says on that's not allowed. You can't do that. That API, that endpoint doesn't exist. So we've basically set up RequestRocket to be deployed in all of these different regions so that you can, so what that allows you to do now is start to prototype, build applications, integrations to different systems using whatever authentication you want, and then layering on top of that whatever authentication you need or authorization you need in order to prevent those people to have access. In terms of the kinds of security rules that you can apply, it's to anything inside that request, or with the exception of the body of the request. So we can pattern match what your the path, and you can set a deny rule on a specific path or on all paths, however you like. You can match against the HTTP method and headers, like for example, you must have this in the header, you must have this in a query, or even in terms of headers and queries, not just you must have this as an attribute, but you also must have this as the value that's associated with that attribute too. And the reason we might like to do that is because there are APIs like the Graph API, for instance, where you can actually gather more data than what that base endpoint allows you, gives you in the first instance by extending and using an extends parameter in your requests. And so we can restrict that behavior and say, no, you're not allowed to do that, or you are allowed to do it, but only for these certain fields. So we have a huge amount of, and unfortunately, as complex as you need it to be, flexibility around the authorization rules. But we can also do something which is quite useful when you're trying to build, for instance, integrations with Power BI into systems like Xero, where you would really love to have a basic authentication that Power BI can secure for you, because they do secure that natively, but they don't handle any other type of authentication with that level of security. So the problem is, if you choose that option, you can't add anything to the header or query parameters of your request. So we need a way to add that at the runtime. Every time we make an API request, I want this tenant ID to be added to a header. And so with our proxy configurations, you can then add whatever you want to every single request in here. The developer actually never gets to see that. You can give them a key and say, here you go, hit the Xero endpoint. You're going to use this. This is our authentication spec. You can use an API key, have fun. They never get to see what the tenant ID is because it's all configured in here. So whatever you would like to override. One thing we're experimenting with at the moment is actually overriding data. And so, a nice example of that, we just heard about, Gemini and tokens and stuff like that. Well, if you want to prevent your devs from making, outrageous max tokens claims on their API request to the different APIs, well, then you can override it and say, no, well, max tokens is always 8,000. Thank you very much. No more from you. So that's all in terms of the demo. And thank you for your patience as we went through that. Back to the presentation, just to close out. So as I mentioned, we are in early access. If you would like to join up to the platform, we're not charging developers for using the platform currently. We do ask if you'd like to join our Discord. We'd love to get your feedback on features, and we quite often are coming out with new features which we talk to our community about before releasing them. Funny story, we didn't think that dark mode was important, but apparently it was. So that was probably one of the first things that every developer on Discord told us about. You're welcome to sign up. It's free to sign up with your personal work account, whatever you like. It's kind of like how Jira works. You can set up an organizational account if you like, invite team members in. They can participate and work on that together. And so at present, we're not charging developers for that access. That'll change soon, but our pricing model will be consumption based. So really easy, basically the same way that you pay for your cloud services. Thank you very much for your time today. And if you have any questions, you're more than welcome to catch me afterwards.